Welcome back, environmentalists, for part 2 of wastewater, septic, and public water systems. We'll be starting with septic tanks on this lecture, so let's get right to it. There are two really basic types of septic tanks that are out there, and they are a type of wastewater treatment plant, so they're just a miniature version of what we see for cities. So they're done for domestic houses. So an anaerobic septic tank is what most people would consider as an old septic tank. Some states would call them grandfathered, and it depends on when they were put in. For example, for the state of Texas, that happened in 1987. That would be a good bonus question for a test. So what is an anaerobic septic system? This is a small wastewater treatment system designed for houses which cannot connect to a city sewer system. So they're very economical because they don't require a whole bunch of stuff to get them in the ground beyond once the infrastructure is installed, and maintenance is very low. So let's look at how they work. This is a gravity-fed system that has one pipe that comes from the house to the septic tank itself, which is underground. And it has a leach field with perforated pipes for draining fluids. So one thing that you need to know, besides the fact that these designs are the most prevalent and the least expensive but are not approved for all soil types, is that if they do break and you do have a grandfathered system, you have to bring it up to today's specs. So that last bullet point of not approved for all soil types is kind of important, because if you have an old septic tank that's an anaerobic or traditional system, at least in the state of Texas, once it fails, and let's say you're in the soil type that can't use an anaerobic system, or you don't have enough leach field land space, then you'll have to change your system, pull out the old one, and put in an aerobic system. So this is how one typically works, and basically the solids accumulate more in the first tank, and then the scummy water goes over here for more treatment. And it's just a single home septic tank is what it's designed to be. So let's talk about an aerobic septic tank and how they're different. This system introduces oxygen into the wastewater. Basically, it's the same setup as we saw for the anaerobic, where the bacteria goes into a settling tank, but there's an additional tank installed, and it's this part right here. And this part right here is going to introduce oxygen into the system, so it actually uses aerobic bacteria instead of anaerobic bacteria. The aerobic bacteria process the waste faster and more efficiently than in an anaerobic system. That's the only bonus here. So it's not like that I'm anti-aerobic system, but I've had one and it kind of got me into some trouble. This system is comparable to a small-scale activated sludge plant where bacteria quickly feast on sludge nutrients. Again, this system is much more effective, but it requires a maintenance contract in Texas, meaning you have to have someone who's a licensed contract person for septic tank installer and maintainer to come out and do a quarterly check on your system. So you're looking at anywhere from 150-ish bucks up to several hundred, 300 bucks a year for them to come out for 5 or 10 minutes, for each quarter. It's ridiculous. You can become a licensed installer, by the way, but there's classes and certifications that you have to do. So aerobic tanks have moving parts as well, and the moving parts actually have spray heads. That's another thing to be cautious of, because they can get run over by a mower very easily, and so they're moving parts that need to be replaced and a maintenance contract. If you have the option, my advice to you would be go with the anaerobic system. So let's talk about the enforcement of septic tanks, because this is a controversial issue regardless of where you are in the United States. Most individual states have assumed regulatory authority from the Environmental Protection Agency, or EPA, to oversee their septic tank program in their state. And they've taken it a step further. They've modeled after what EPA did with the states and gave them the work to do and said, hey, we want to give this to the counties or political subdivisions who want to provide a local service. So basically that means each county in the state of Texas has the option of becoming what's called an authorized agent, or an AA. So the State Department of Environmental Quality will transfer their regulatory authority over to a county or a political subdivision. Let's say it's a health department that wants to perform septic tank inspections and enforcement at the local level. You might go, what's in it for them? Why would they want to do it? Why would they become an authorized agent? It all boils down to money and convenience. They can charge a fee for the designated representative to go out. So the DR, designated representative, is the actual person who is licensed to conduct septic tank investigations or inspections on the behalf of the authorized agent. Typically, the authorized agent is a county judge, and I have met a lot of county judges when I worked for TCEQ, but none of them were designated representatives. So I guess it's possible that they could be, but I've never met one, and highly unlikely. They have other jobs that they're doing. So the designated representative only gets a portion of that money, and the county gets the rest of it. The other benefit for having the authorized agent program in a county is that it allows your constituents, that people that vote for you, that live there, to get faster service and turnaround for both getting a permit to build a house that requires a septic tank, and second, to respond to complaints for failing septic systems that typically stink. So both things provide faster service than having the state come in and have to deal with it. For example, when I worked at TCEQ, in our regional office, we only had one septic tank investigator for 20 counties. And of those 20 counties, we only had one county that was not authorized agent. So that kind of tells you we had all of our complaints come in primarily from that one county that wasn't an authorized agent, and it required most of the time of that person. So let's look at public water systems. These are drinking water plants. Make sure you note that in your lecture notes somewhere, because they're completely different from wastewater plants. Wastewater treat wastewater to be a higher quality. Public drinking water systems treat surface water or groundwater to become safe to drink. So the standards are completely different. Higher set of standards, more stringent set of standards for PWS, public water systems. What makes a public water system a PWS? This is any system that distributes water as outlined by the Safe Drinking Water Act of 1974. Both requirements must be met to be considered a PWS, or a public water system. Requirement number one, the system has at least 15 connections, or, and I underscore or, at least 25 people or persons it serves. So you could actually have just one or two connections, and there'd be 12 people on each connection if they were smashed into one house, or it was a large house. So 15 connections or 25 people. The second requirement is that they must provide water for drinking for at least 60 days of the calendar year. So why is that important? Let's say you have a transient system that only operates for 40 days in the summer. Maybe they're like a little camp and they're only open for 40 days in the summer. That might be an example. So you have to have both things that it meets. So if you're serving at least 25 people for those 60 days, that makes you a public water system. But remember, you have to meet both requirements. So make sure that you know how many connections, how many people, and how many days it must require. So once you get to become a public water system, whether you knew it or not, you are permanently a public water system. So as I mentioned, once designated as a public water system, the federal law mandates that the system provide ample and safe drinking water to its constituents, which are its customers. If it goes bankrupt or abandoned, the state or EPA will assume operation of the system until another owner and operator can take over the system. Once you, as the customer, establishes contract with a public water system, you are expected to pay for that service. To terminate service, the public water system must notify the customer when the service will cease with ample advance notice, and this usually occurs because of non-payment. And the same would be true if you're stopping service as the customer. You have to give them a certain amount of days notice so they can adequately shut that service down. Public water systems sometimes have of need to issue what's called a boil water notice. So when a water treatment system fails or experiences water outages, this could be the reason that a system may need to notify its customers. So when this occurs, it may trigger the officials of that water system to issue a boil water notice. So what's a boil water notice and why is it required? A BWN or a boil water notice is issued when the water may not be safe to drink, or it could pose an imminent health threat to the customers of that public water system. So interestingly enough, the public water system notifies the State Department of Environmental Quality first, and then notifies the public within 24 hours of discovering the need to issue the boil water notice. Why does this occur in that order? Because they need to let the entity that regulates them know first, so it initiates the process, and then they got to notify their customers within 24 hours. So failure to do so is grounds for enforcement. What causes the need for a boil water notice? Here are a few causes of BWNs. Water line pressure drops below 20 psi, or pounds per square inch. So if it drops beneath that level, that is an optimal recipe for bacteria starting to build in the inside walls of water pipes. So that's not a good thing, because the bacteria can be a food resource for the things that really make us concerned and sick. And even some bacteria can make humans very sick. Maybe a water outage or inadequate disinfection levels. Maybe your chlorine just stopped working, or your ozone treatment stopped working. A water line breaks or ruptures that can cause this process to occur. If you have groundwater wells that you're pulling drinking water from, maybe you have a problem with the actual pumping system, or the equipment or the storage of your drinking water fails. Or maybe a disaster hits, like a hurricane. So when big hurricanes have occurred, that can knock out power, it can flood the system, and that system can no longer produce safe water. So what must occur when a boil water notice is issued? The public water system is required by law to use the most effective method of reaching their customers on the system. That's going to vary from system to system, and I might also add could vary based on circumstances like a natural disaster. Most of the time, public water systems will use a variety of the following that I'm fixing to discuss: television broadcast, paper announcement, neighborhood signs, internet announcements, radio broadcast, and even door-to-door hangers. Door-to-door situations can occur in very small towns that don't have the resources to do the others, or in a situation of a natural disaster like a hurricane. So if you read this standardized boil water notice, it's kind of funny, because it's the template that's used for all water systems pretty much. It basically says bacteriological analysis of samples obtained from your water distribution system have shown possible contamination. As a precautionary measure, we advise that all water used for drinking or cooking be boiled. A rolling boil of 1 minute is sufficient. As an alternative, bottled water may be used. Might I add something here that's not in there? Bottled water is not regulated by the Safe Drinking Water Act, just FYI. The precautionary boil water notice will remain in effect until the problem has been corrected and a bacteriological survey shows that the water is safe to drink. If you have questions, contact Joe Chlorine Clean Water Utility at XYZ phone number. This is basically cover all the bases for legal reasons until the water is proven safe to drink again. So boil water notices are important to follow. How is a boil water notice lifted? The public water system can lift the boil water notice once the following has been achieved. The first thing is that they've corrected their problem. Second is the public water system disinfects the system. That kind of makes a does sense, but let's say you have that bacteria growing inside the pipe, you want them to disinfect it and flush it. The public water system verifies the system is not contaminated with bacteriological agents. And last but not least, the public water system receives permission from the State Department of Environmental Quality that it is appropriate and approved to lift that boil water notice. The last thing that we'll discuss in this lecture is consumer confidence reports, known as CCRs. EPA requires that every public water system deliver an annual water quality report to their customers. You may not have even noticed it, but it probably came in your water bill. This allows citizens to make practical, knowledgeable decisions about the health of and environment of the water that they drink. This report contains water quality data from the previous calendar year for the drinking water, not wastewater. We're only worried about drinking water where people are going to put it in their mouth. And EPA requires that this report be distributed to customers no later than July 1st of every year. And it serves as a public notification to customers if a system has discovered a violation of a contaminant standard. So a system may not have a contaminant standard violation at all and they have a clean bill of health. Well, they can report that in their CCR, but they have to show what the maximum contaminant level is for every constituent they're required to test for and what their actual numbers were, whether they're below, at the threshold, or above it, and they're busting the limits. So this could be important for someone that may have an elderly or a very, very young child in the house, like a baby, that could be ultra sensitive in the population to something that's on that list, some kind of constituent. So be careful and read that thing. If you don't know how to read it, ask your water system to help you interpret it. So let's get to our science servings. Yay, it's time for science servings. Please don't feed the storm drain. You've heard a lot about storm drains as we were talking about fog in our stormwater lessons, and we revisited that in wastewater. This is the basic symbol, which is the face, the smiley face. It's not smiling, it's gagging because of what's being put in the storm drain. Let's talk about how long it takes for a water droplet to go through the wastewater treatment process, like at an activated sludge plant. The average time a drop of water stays at a wastewater treatment plant is about 7 hours from the moment it arrives as effluent until the time it departs the site as effluent. That's pretty fast. It can go faster if the system is overloaded because of flooding, but we don't want that to happen because it needs to have adequate time to be clarified and treated and then disinfected. The chlorine content residual time is required by law to be at least 20 minutes. And you're looking at a chlorine residual chamber right here. Another important type of technology that's used in wastewater is also a drinking water technology known as dissolved air flotation, DAF plants. Waco, Texas is home to one of those types of plants in the United States, and there's only just a handful. This wastewater technology is used both in wastewater and water treatment facility, and how it works is just the opposite of like a septic tank and the aeration basins we talked about for activated sludge plants. What happens is it injects millions of compressed air bubbles into raw surface water, and this pushes up solids which are skimmed off and sent to a wastewater plant for treatment. So the clean water gets disinfected before it leaves the dissolved air flotation plant and then is sent on to a public water system for treatment. At least that's how it works in Waco. In theory, it actually meets water standards before it leaves there. It still must have enough time in the detention basins in order to meet the definition of a public water system. As I mentioned earlier, bottled water is not regulated by the Safe Drinking Water Act, specifically the Clean Water Act. Anyone can be a bottled water distributor, and the United States Department of Agriculture is the one that you would report to because they have specific labeling and requirements. This is tap water. I'm not joking. So what's purified water? I'm not joking when I tell you this. It's tap water. And it's tap water that has typically gone through additional filtration to improve taste and odor. So when you pay for a bottle water anywhere and it has purified on it, you just paid for tap water. Now, having said that, if you paid for tap water, it came through a public water system. So going back to that boil water notice, if I had to choose a bottled water during a boil water notice, it would be purified, because purified, I know if it's in the United States, it meets the Safe Drinking Water Act because it came from a public water system to begin with. So as we conclude our thoughts, looking sharp is easy when you haven't done any work. So we want our wastewater plants, we want our septic tanks, and we want our public water systems to be at work. We want them to do their job. We want them to meet the standards, because it's a risk to human health and the environment if they don't. I'm looking forward to seeing you in our next lecture. Bye.